Okay. So we talk about a Gaussian mixture model. So if it is a distribution, any of distribution, suppose we analyze it. So this is a Gaussian here. So this one big peak. So there's the Gaussian here, the ray one. Suppose the ray one here. This is ray one distribution, and then the blue one is the other one. And do the third one. Just for example. So we have a third, suppose third one is here. Distribution. What I try to say is that because original this doesn't do that the Gaussian. So if you use one Gaussian, but it doesn't do that Gaussian of the original distribution. So if I use suppose the Gaussians, the red one, the blue one, the green one, it looks better than only one Gaussian. Okay. So that means if I use more than one Gaussian to model the original distribution, we call Gaussian mixture model. So the result should be better than only one Gaussian. So more than one Gaussian to modeling, we call mixture. So the Gaussian mixture model. So that's here. So this is just example. I always try to use the example to explain to you. Okay. So how many Gaussian distribution we will decide to have we use a vector quantization. We call clustering. So when we decide before we use the Gaussian mixture model, how many Gaussian we will apply for this distribution? We use a vector quantization. I will teach you vector quantization later. And VQ is one method. They will decide for you how many clusters they can have for any distribution. So suppose in our case, this case, okay, and we use VQ, suppose they can classify, they tell you, okay, this is the distribution after VQ, they say, okay, you have total 3 clusters. 它会自动帮你做分类。它会讲说，我有3个可以分成3类，那就3个Gaussian distribution。So 这到底几个Gaussian就是用 VQ 来做？那这样的话就是 K 等于3，那就是意思是说 J equal to 1 to 3， 1 to 3， 1到3就3个Gaussian。那每个Gaussian都是用一个Gaussian distribution来 model 它，就这样。所以 Gaussian mixture model is easy but important. So for each Gaussian distribution, they have their own mean, 它有自己的 mean, their own standard deviation, the standard deviation. So each Gaussian, this one, they have their mean value. 这个Gaussian有个 mean 平均值在这里，这个Gaussian有个平均值在这里，这个Gaussian有个平均值在这里。就3个面，3个Gaussian，3个面，然后自己 standard deviation， 这就3个Gaussian。What's W? W is weight. Weight of what? Weight of number of samples for each cluster. For example, suppose this first Gaussian, suppose they have 100 samples. This is 50 samples second. This is also 50 samples. So total has 200 samples. So first one is 100, so it will be half. Weight will be half. and the second one will be 1/4 or 1/4，1/4嘛，1/4嘛，所以它 weight 就1/2、1/4、1/4这样子。就是你每个 distribution， 这中间会画一条线过来，分开嘛，交叉的地方会被把它分割来，所以是左右两个，所以这个 weight 的，就是你每个高讯 distribution 占的 sample 的个 total sample 的占的total sample 的比例是多少，就 weight。那 weight 很重要。高讯 mixture model 的 one important one is weight。So right now, your Gaussian distribution here, the Gaussian distribution, your parameters is only mu and the low standard deviation. But Gaussian mixture model has one more weight, we call weighting WU low, just 三个. So Gaussian mixture model has 3 parameters. But those 3 parameters, you should give him the initial value. But after you give the initial value, we can optimize those 3 parameters by EM method. EM method. E is expected. Is actually the average value. And M is the maximal likelihood. 这样子。我要讲一遍 ，you want to the initial value of the mixture Gaussian model is based on the VQ. So VQ based on VQ, you have 3 clusters. Each cluster you can find a mean value, you can find standard deviation, and also you can have the number of samples, and number of samples divided by total samples, W. So both, sorry, 3 parameters, they have an initial value by VQ. After you do the VQ, it's not the final result. You want to optimize. You try to find the best 3 parameters for each Gaussian. You should use EM method. 就带进去就帮你算出 EM. E is expected and maximization. 这个都有式子可以让你套。这样子，这样就算求出来了。So this kind of process we call the Gaussian mixture model, but it's also parametric model. 这是有参数的，这就3个参数的 model 可以算出来的，这叫参数型的 model. So what's a non-parametric model? 什么叫非参数型 model? 有这2种哦。你说哪一种比较好？参数型的 model. Which one is better? Non-parametric model is better or parametric model is better? Usually, parametric model is slow. Actually, non-parametric model is better. It's faster and better. But it need space, memory. Non-parametric model needs memory. Parametric model, because you need to only set the parameters, so you don't need space, you don't need memory, you don't need a large memory. Parametrics 因为它是参数化好处是什么？就是参数啊，就是有参数，你不用存原来的 data， 所以它省空间。但它会因为它是参数型，所以估计就误差，它会误差比较大。那 non-parametric model 它的误差比较小，但是它需要 memory， 这样子，它需要 raw data， 然后它要存 raw data。非参数型的 model 需要存原来的 data， 它没有参数，需要原来的 data， 所以它吃掉记忆体。参数型就是你把任何东西都变成参数化了，像高讯一样，你就是明明跟 standard deviation 嘛。然后有误差大，但是空间节省， 所以各有优缺点，看你怎么去用这样子。那这个跟 reinforcement learning 一样，reinforcement learning 事实上是往非参数型走，但它有参数，它参数就是我们的那个 network 的参数这样子，但它需要储存 raw data， 所以它有点混合。好，我来讲为什么那个需要 memory 来看这个，就是 non-parametric model has better result. Why? Okay. First of all, the same they use both the Gaussian model. 同样的高勋 model， 同样高勋 model 有两种，一种叫参数型的高勋 model， 一种叫非参数型 model。事实上，任何的 model 都 any kind of model has two kind of model, parametric and non-parametric. Parametric is easy, just use it. You just use it. Non-parametric, you need to think about how can you do for that. 非参数型你要去想怎么去处理这个问题。那这里是一个例子。So this is a model, look like a Gaussian model. A non-parametric model meaning you don't have a mean, you don't have a standard deviation, but it's still Gaussian model. So what can we do? Is this way. We see this one. So original here is subtract with the mean value, right? Mean and inside here standard deviation. 这是一个那个 covariance matrix， 所以 standard deviation 在这里。Mean is here. 非参数型 model 没有 mean 嘛？那是什么？ So you need to have a buffer. Suppose I save 60 images each time. Actually 60 pixels. For the background subtraction, no matter is the parametric or non-parametric, that's meaning this model is for each pixel. So suppose your image has a 640 by 480, or your image has 2K images. That's meaning you need to have a 2K Gaussian models, because one pixel is for one model. Background subtraction is one pixel for one model. 每个 pixel 都独立的。那这里是一样 ，one pixel for one model. Now for each pixel, suppose you have buffer. Your buffer, you save suppose n equal to 60. 60 means 2 seconds. 1 second has 30 frames. So 2 seconds is 60 parameter. That's sorry, 60 pixels here. So you have buffer. And if you have 2K, you have 2K buffer. Each buffer need to set 60 parameter and 60 the gray value of this one for each pixel. And right now for current pixel, you need to compare with the 60 pixels. So you subtract each one and you do summation. 假设你的 buffer 有60个 pixel， 你每个 pixel 这个每个 pixel 都要跟你现在进来这个 pixel 跟这60个相减。刚刚只要减掉一个幂值 ，the Gaussian model you only need to subtract with the average value. For the non-parametric model, you need to subtract with each of the value in the buffer. So this is more reality. 这就更实际嘛，对不对？你就减掉实际的值去比嘛，所以它需要吃掉 memory， 但它结果更好。所以命被取代掉了，没有命，这样可以吗？这就没有命了。所以但是你要 buffer， 然后直接两个相减，就你原来的命现在没有了，你只要把原来的原始值来做相减。这样结果会更好，因为它更接近原来的。How about standard deviation? You need to normalize. You need to divide by standard deviation. 这个是它的那个就跟这个一模一样，这个 一模一样 ，standard deviation，对不起，这里 page 19，那这个值怎么取代？这个值怎么取代？那它是这种，它这篇 paper 用这个方式取代，用一个值取代，这个值是什么？那我猜，因为他没讲，很多 paper 在 non-parametric 很多 paper 不跟你讲他的方法，他讲了他秘密就让你知道了，他是故意不讲，因为他是他的 know how，他只跟你讲说我用这个值来给你，所以我到现在为止还搞不清楚这个值怎么来的。这篇 paper 这篇 paper 蛮有名的。Now, I think it is way. You have a mean, right? So suppose the Gaussian distribution we want to take 95%. So that's meaning okay, then this one. This one we want to replace the standard deviation. So how can we replace this one? So this one suppose this value. This value they equal 2 is here and mean is here. But they told you don't use mean value. Average value is not good. Median value is better. Why? Because of median filter. Median is so if after you do sorting of what? Sorting of this one. You have 60 values. If you do average, because sometimes some value has noise. So if you do median value, you can ignore the noise. So they said, okay, we find a median value here. So this median value will become this value. So they say this is median, this is not average, it's median value. And this one is from here. Because it's square root. So they do this. They do this square, so they do square root. And I don't know how they come this one. So that's meaning this value, this standard deviation. Okay, this will be their standard deviation. 它是设计这个值 But this value is dynamic. They will change based on the median value. And median value will be affected by the buffer, by this buffer. Okay. So the result is better because they don't use mean value, they use the real image. And also the important thing is that each time they save 60 pixels. Okay. And if a new background pixel, they will update this one, they'll come in here. And the older one will older 是最旧的 data will delete it. So this buffer this will be the other story. So how can we save this buffer? Suppose it's 60 pixels, right? So if we have a new background model, background pixel here, they will come in here. First in, first out. Sorry, this first in, first out. 新进来，然后旧的丢出去这样子，所以这里一直维持60个。So that's meaning this is change, and then this median value is always change. So the result is better. So my conclusion is this way. So it's non-parametric actually is how do you design the non-parametric model, and they design by this way. Just giving some value, but this value is based on the median with some constants value. So 我们读 paper 最讨厌就是他跟你讲这是一个 constant value， 他不跟你讲它的这 constant value 是什么。常常有些很好的 paper， 纵使好 paper 他是这样跟你讲，因为那是他机密，他不跟你讲，要踹出来的这样子。OK， 那这个就基本上这个就是我们讲的那个 non-parametric model。我讲的是最基本的高训的东西。那 deep learning 里面 ，deep learning 有没有某一个部分属于 non-parametric model？ deep learning 目前没有。 我没有看到这种 paper，会不会有？我不知道，因为 deep learning 的参数太多了，不知道。那高勋是比较简单，但是我讲不止高勋，很多 paper 他会跟你讲是 non-dimension model 的话，这是表示你这个 paper 你可能值得注意一下。但是如果 set 没有人 set，那你不要理他，那就是乱七八糟的。如果有真的 set 很多的话，这个要注意一下，因为这个里面表示它有很多技巧在里面。那 reinforcement learning 有部分是用到这个 reinforcement learning 才会用到这一方面，因为它用到 buffer 的技巧，这样子，就这个 buffer 的技巧，就要吃掉 buffer。那我们再继续。那 so far if you do this way, the other important one is that right now you use a deep learning model, right? And you try to try to do your best. You want the deep learning result is the better or the best. But I would suggest you actually don't need to work so hard for the deep learning about that. Why? Because of the we call post processing is very important. 就说你在做 deep learning，你们现在就拿 deep learning 来用，希望 deep learning 出来结果就是最好，很好，非常好。但是有时候心态你改变一下，就是说你有时候还是需要一些后处理，不然你这边很难，有时候很难改，它已经被你压榨的差不多了，你再怎么改都改不出来了，而且你到最后你也没有能力去改了，所以要做后处理。所以我一直说，前面有些 deep learning 大概这样就够了，你宁愿让精确度提高，但是误判率也提高。那还有因为你还可以做后处理，我这里跟你讲有哪些后处理可以做。So post processing for any kind of modeling. Deep learning is one kind of modeling. So post processing for any model is important, very important. That's why we still need to teach you image processing. We need to teach you the computer vision. Machine learning can replace by deep learning. 我一直强调一点 ，deep learning can replace machine learning, but some computer vision technology or image processing technology, you still need to use it. For what? For pre-processing or post-processing. 你不要没有能力去做这种后处理。那我自己学生，我发现目前的学生，因为你们现在好处是很多 library，但是你们的坏处是你们的后处理能力变差了。为什么？因为你们没有办法，就简单讲，我只随便举个例啊，就是 H detection 你能 call OpenCV 的 Sobol H detection，那我叫你自己写个 Sobol H detection 的程式，你会不会写？因为很多学生居然不会写，包括我自己学生居然不会写，那就是你能力变差了，是这个原因。因为你现在 library 越来越多了，但是 post processing 基本上是没有路哦。post processing 上后处理上没有什么路，是根据你目前的结果去把它提升什么？不是提升，降低 false alarm，精确度好了，我怎么用后处理把精确度维持住？但是我把错误率降低，这是 post processing 的目的。我想把错误率降低。好，那我们来看这个，这举个例，举这个例子，他说要 suppress of false detection， 就是 false alarm 误判了，他把它压低。我是举例，我都举例好。那我们做到这里为止，做到这里为止，这个回到这边来讲，因为 it's pixel wise。So far, no matter it's a Gaussian model or non-Gaussian model, what we did is a pixel by pixel. We call pixel wise, W-I-S-E, pixel wise. In deep learning, we will call channel wise, element wise. Deep learning has a channel wise, one channel be a unit. They have an element wise, that's pixel wise. deep learning is both kind of channel wise, element wise, pair wise，deep learning 也有一模一样，都一样。那 this is pixel wise, that's meaning you process pixel by pixel. Okay, but because pixel by pixel, so after the process, you'll find there a lot of noise here. Because pixel by pixel, it will cause some false alarm， 就误判。误判什么？就变成杂讯，误判这有物体，这有前景。你误判了这有前景。So how can we reduce？ 我讲 ，How can we reduce those kind of false alarm？ 错误率。我再举个例，我们跟成大医院胸腔科做那个肺结节、肺癌肺结节，我们也是一样，这个都会存在哦。我们跟公司合作，做了20几年，都一样。你在 when you do the research, first of all, you need to try to have a better accuracy or better we call recall precision。你要把正确 recall precision， 你要把正确率至少提高起来。当你把正确率提高起来，误判率就跟着提高，都是这样子的。就 detection, tracking, recognition all the same。但是你要想办法，不管你用什么 model， 包括 deep learning 的 model，deep learning 是一个 network model 里面，你都先想办法把你的 precision or recall 先把它提升起来，然后再想办法把错误率降低。这是都这样子做，这样子做才对。OK， 你没有办法提升起来，人家不会用你。那我举例来讲是说，我们跟医生合作的话，因为你误判率高的话，他是希望你帮他做完肺结节，他只要最后就是他本来要假设他本来要看400片的片子，他能不能信赖你？他只要看其中的10片再做 double check。另外有一点很重要，你如果跟医学合作的话，你不要想要取代医生，这是错的，是做辅助工具。医生角色、专业角色永远没办法取代，你要去尊重人家的专业，就像你的角色没办法取代，是因为你这样做才会，你的思考跟做的才会有效果，所以你要做辅助工具给他用，去帮助他。就像我们现在我们都有近视嘛，我们去看眼科医师有没有？像眼科工具最普遍的，你去眼科都是先帮你做一些前处理，然后最后你好不容易做完前处理，医生只跟你讲1分钟你就走了。感觉好像你也会可以当医生，因为好像他是看那些报告结果就会了，不是啊，他是帮你做最后判断。但是我说因为我们眼睛上目前我不一定对，但是目前看眼睛这边就最被破解最多了，最了解是眼睛算器官里面眼睛算一个被破解最多的，所以很多仪器就是很多仪器发明。但是我说，你只要跟这种人有关的，你不是要取代他，你要是辅助他，这样你做出来的那个，就你方向对了，你做出来的才有用。但是你在像我们跟其他公司在做那种自动化的话，他不需要你 double check， 他希望你就直接取代那些女工那些人力的。为什么？因为一个是生命，一个是没生命的。最主要在这里，生命就是你误判的话，你可能会一个人生命就没了。那公司那边你误判的话，那就还好了，没有人会死掉。那就分了 A 级品、B 级品嘛。你买的面板有 A 级品，A 级品是种良率比较高的，B 级品就是良率比较低一点的，就这样子。他就这样，他用这种方式来 ，B 级品可能要淘汰掉，但是卖你便宜一点。所以你买电视的时候，不要以为说，哇，这个5万块那么贵，然后 Sony 的7、8万更贵，然后你买我买个2万块的可以啊，那都可以看的，你有没有看那么仔细？但是这面板是不一样的，因为那个良率会不一样，这样子。对，所以这两个不一样，一个是有生命，一个没生命。那我们要做的最主要就是说， 我们希望帮医生是让他在某个可信度之内，你本来看400片，他就只要看10片就好了。你可以帮助他这样，所以意思是说，你还是可以容许一些误差，但是你要把 false alarm 降低，误判率降低。那this is one example to this one, so they call suppression or reduce of false detection. So you think about original is pixel by pixel. This is pixel by pixel. So now on page 28. So they have two methods. They combine together to reduce the false alarm. The first method is this one. The first equation is this one. This is what is meaning you need to because it's pixel wise. So right now you need to consider neighborhood, like a Kenny edge detection. You need to consider the neighborhood. So suppose the neighborhood, suppose a 3x3 window or 5x5 windows. But in this example, it's 5x5. They feel 3x. This only need to test. Which one is better? I don't know. You need to test 3x3 or 5x5. So if they test the 5x5 is better. So suppose for any 5x5 pixels, for all the they try to find a maximum value. Maximum value is what? Is background pixel. Background pixel. Because we need to detect the background. So background, 我们现在是把 background pixel 的几率值比较高哦，你不要搞混了。我们现在是那个 background saturation 主要是把 background threshold 高的是 background， 所以我们把最大值求出来，当成这个值的几率值。意思是说 5x5 pixels, 25 pixels, we only pick up the maximum value to be this pixel. I say again, original is only 1 pixel, but right now it considered for each pixel it considered 5x5 is 24 pixels, and you pick up the maximum value to be the probability of that pixel. 就我现在我这个 pixel 我考虑到我邻居25个点，这25个点的最大值取代我这个值。为什么？因为你为了避免这误判，我假设我这里有个值嘛 ，original this pixel is a foreground 里面那个值比较低，几率值比较低 foreground。But this pixel I consider my neighborhood 25 pixels. If any probability is larger than this pixel, it's meaning that's a background pixel, and then this pixel will be reduced, deleted. 你懂吗？这些杂讯就很多都不见了，因为 background pixel 是我们要的，我们那几率值 background pixel 是比较大的，因为我们是纯 background pixel， 那 foreground 值比较低，这样子。所以避免误判的话，他把这邻居里面只要有存在比我还大的值，我就被取代掉。那上比我大的值表示我那值是 background。那意思是什么？意思是那个 tree 嘛，那个 leaf 叶片这样在动嘛，叶片是 foreground 会动，你会被侦测到。但是叶片动的话，你假设这叶片每1秒钟动到一个位置，它搜寻一个范围，这范围只要有任何值是 background 就是大的值，那我这个叶片就被这个叶子就会被这值就被取代掉。那这对呀，所以我就比较不受杂讯影响，所以它这是对的。所以第一点就是，我希望考虑我的 neighbor 里面，我的 neighbor 里面，只要有 background 的值，我就把 foreground 这个值杂讯把它去除掉，所以它减少这个原因，要减少这个 noise。But at the meantime, they will overkill， 它会过杀。过杀什么？它会把这是一个例子，后面page 23 is exactly the example. So the person here. So first of all, if I do background saturation, you see the result will look like this one. pixel wise, pixel by pixel. So you see a lot of noise. Also, there's shadow. 这是阴影哦 ，shadow is here. A lot of noise. So if I use this method, use this method, I will try to keep more background pixel, and then I will kill a lot of background, but also I will kill a lot of foreground pixel. 他把一些 foreground 都 sorry，they will kill a lot of foreground pixel， 所以连这个 foreground 都把它去除掉，就 我们称为 overkill， 对，会杀掉很多 pixel， 过杀了。那过杀我们怎么办？就再把它补回来啊。啊，所以 post processing 你要去想，当我找出一个方法出来，可能会引起另外一个错误，所以有时候难在电脑视觉，有时候难在这里，很难找到个平衡。而你找到你就很强，这会过伤。就像我讲，我不行对啦，我说我听我同学在 Google 他在说，他在讲，因为他有同学在 Tesla，Tesla 为什么放弃不要用 LiDAR？ 为什么要用 RGBD 摄影机，不要用 LiDAR？ 我也想不通啊。我觉得 LiDAR 我有用，我觉得 LiDAR 很好用，我叫学生一定要用 LiDAR， 就 RGBD 跟 LiDAR 都要用。那 Tesla 不是放出一个消息说，他们放弃用 LiDAR， 看哎，那很多人是不是跟着放弃？可是我是专家，我觉得不对啊，我到底怎么样？这时候就你的好朋友就发挥作用，就问我Google 的朋友、美国朋友，到底怎么一回事？就帮你问，就问他 Tesla 的朋友。结果是因为我上次好像提到嘛，因为那个 LiDAR 常常会就最后判断结果 ，LiDAR 跟 RGBD 摄影机会起冲突。LiDAR 说那边有个物体，你要刹车，可是 LiDAR 比较远，它很早就看到了有个物体，你要刹车。而近一点的时候，那个 RGBD 摄影机跟你讲说，不对啊，那个物体根本你有 texture，LiDAR 没有 texture，RGBD 有 texture 嘛，那个物体不重要，开过去没关系。这两个就起冲突。那他不需要测试说看到远就刹车，然后等到近就把它开了，你的车子就在摇动嘛，变摇车嘛，奇怪啊，所以他们可能他们还是还没有做，老板这样讲呢，但是不一定呢，他们还是会用的，只是还在评估了，所以这件事情还在评估，对，所以他避免这两个冲突，他们的假设，老板是觉得说，因为人都没有来打，人都用眼睛看，既然都用视觉，既然 computer vision 我们开车都用视觉看可以成功，为什么一定要来打？就这样子啊。所以这件事情还没有，但是我同样的会起冲突，我们在做研究会起冲突，那这个就冲突了 ，overkill， 那怎么办？就回到这一边，所以它补救方式是就加一个connectivity， 就是 component displacement property， 你可能看不懂这个，它是 connectivity 的，它意思是说，当我这个 connectivity 就是 if you connected component 就是有连在一起的物体，你要想这个 background 是单点 background noise 是单点是那个 salt and pepper。foreground object is a object connecting component 会连在一起。那你这样做完，是不是你把里面的东西杀太多了？但是this is a connecting component。So how can I recover the pixel inside the body? Because body the physical meaning of body 物理意义的 of body 就是它是个连续的物体，连续的那个 pixel。所以他现在就去设计，根据这个物理特性来设计说 ，OK， 它就相乘，就是说，假设我这个同个物体在某个范围内同个物体，我把这些几率值全部相乘。If I multiply all the probability to the same connecting component， 只要连续，因为你可以用 CC labeling 嘛，CC labeling 就有个物体的 the objects. So CC label is very important, very useful and very important for the CC labeling. That's image processing. Image processing now叫 CC labeling. Now CC labeling, if I multiply all the value of the component, kinetic component, this value should be very small because foreground value is small. So the summation, the multiplication result, this value should be small. So it's meaning if the value is the kinetic component, and this kind of a foreground you should not kill. You only kill its individual points. You should not kill the kinetic component points. So this value should be low. So based on both value, they have a two threshold. One threshold is try to overkill. The other threshold is try to save the overkill of components. So this is kinetic components. This is individual point, and they should end together. So need to your programming, your code should be both should be ended together. And then if this is not satisfied both point, you will delete it. 就你这两个都不满足，那你才会杀掉background这样子。所以用这个来弥补，你懂吗？就是你在 overkill 之前，你要去 you think before overkill, you think whether it's a kinetic component. Both are satisfied, and you will kill it. So this result will be this one. You can kill the background. So finally, see the same. You kill the background, but keep the foreground components. And the final one is the shadow. Yin. Now, yin, how can we delete it? It is very simple. This method is not a good method. Many people talk about how to delete the shadow, but this is an easy method, but not a good method. What they say is that if you normalize RGB, so R and G, you normalize it, and based on the R and G here, 那这不是好方法，不要用。Don't use this method, but this is not a good method. This is based on RG and lighting. Okay, if there is some ratio, there's some ratio. So it's meaning if this object, this is more darker in this threshold, but the range of threshold is bigger, and then you delete it. 就是你会发现这个东西，当它这个比较偏暗灰色的话，就把它杀掉这样子。Idea is correct, but the method is not good. So usually, how can we delete? How can we delete the shadow? We use the HSV. We transfer RGB to HSV domain. Delete the background. So delete the shadow. Shadow is a background. We will delete it. Shadow is not a foreground. 这是光线。那大概I think that's it for the background saturation. One more term for background saturation we call long term. This one in page 29. Page 29. So background saturation. Okay. First of all, with the Gaussian model. Mixture Gaussian model. The second, we need whether parametric or non-parametric model. But usually non-parametric model is better than parametric model, the result. But it take the buffers, it take the memory. Okay. The third one is any modeling, probably we need post-processing. 我们要后处理. Now, post-processing is nothing about the model parameters. It's separate difference. So the sense of a deep learning. So don't try to get the best result from the deep learning only. Sometimes your output of deep learning still needs some post-processing. The final one is we call for our like this kind of a background subtraction, we have a short-term model and long-term model. That's the other idea. It's also very important. What I say background subtraction is real time. This is real time updating parameters. 这都是做 real time 的 updating 呢。那 real time updating 又分为 short-term modeling and long-term modeling. That's meaning, suppose every 100 samples is 100 frames. 100 frames is like 1 second, 30 frames. So every frame or every 3 seconds you need model, you change your model. This long-term models. This one is 300 seconds, or even though 1 hour, you change your model. So this is very important for the updating your model. So this one is the Kenny edge detection. I did not teach Kenny here, but I teach Kenny in the other undergraduate class. See, Kenny edge detection, they have a softball, right? After softball, they have two steps. Actually, one is overkill. The second is connectivity. If you feel the same， 我在教那个 Kenny edge detection 在另外一门课的时候，你会发现它有5个步骤，后面2个步骤是不是都一样？第4个步骤就会产生 overkill， 第5个步骤就是 connectivity， 它要把它拉回来。你会发现都是这样在做。你自己回去想一下，如果有修另外一门课，所以这里的你发现这里的后处理跟 Kenny edge detection 后处理类似。他先想办法把 noise 降下来，可是会 overkill， 他把降下来的 noise 把它拉回来。好，那最后这里有个很重要的，你要做 modeling 的 updating， 就是这个 short term 跟 long term updating。你要想刚刚那个，一个是 overkill， 然后第一个是把它拉回来。那 here 你要想一下，那我多久要 update 我的 data，update 我的参数一次？我多久要 update 一次？那 Kenny edge detection have 2 thresholds. Usually, edge detection only 1 threshold, right? You do softball edge detection only 1 threshold. Now, why Kenny is better? Because they have 2 thresholds. 它有2个，一个 low 的 threshold， one is a high threshold. 相同的道理 ，Kenny edge detection is spatial domain. It's only 1 image, so it's a spatial domain. Here is temporal domain， 这是时间轴的 domain。那时间轴 domain how long? If you update it every frame, your process will become slow, right? 你如果每个 frame 都 update， 你的时间就变，你不要做 real time 变成没办法 real time。所以他说，那我每3秒 update 一次，那是可以。我每3秒再参数 update 一次，这可以。但是光线一直变化怎么办？所以有个 long term 的 updating， 就是可能每1 hour you update again. So every 3 seconds you update parameters. Every 1 hour you update more parameters. So that's called, we have a short-term modeling and long-term modeling. But what's the difference for the short-term modeling? You see, this is a short-term. We call sensitivity here. Here is meaning you update quickly. Every 3 seconds you update. Update is meaning you don't change them. Your buffer first in, first out. For the long term, you delete, you clear all the data in the buffers. 2 things. The update is the same, but difference is the buffer. For the short term, you first in, first out. That's fine. For the long term, they delete all the buffer information, all information in the buffer, and they collect the new information. 这种就是这么 long term， 这我待会再讲，我先下课。就 long term、short term 这个很重要。Okay, we take a 10 minutes break.